In today's lesson, we're going to look at a continuation from Math 2, our geometry section on similarity and circles. Now, similar shapes basically have the same shape, but they're just different size. It's called a dilation. So if you look at these two triangles, the triangle on the right is twice the size of the triangle on the left. So this has a scale factor of 2, or actually how we're going to write it is 2 to 1. We always want to write our scale factor as a fraction, even if it's a whole number. So let's figure out how to figure out this scale. I think we can see the scale factor for those triangles just by looking at it. 12 is double 6, 16 is double 8, 18 is double 9. I'm going to show you an easier way to actually calculate it when maybe the numbers aren't as easy to see. Given that all circles are similar, determine the scale factor necessary to map circle C to circle D. Now in example 1, circle C has a radius of 144 units and circle D has a radius of 3 units. How you want to do this is you want to write a scale factor as a fraction, always of your final unit over your initial unit. So my scale factor is 3 over 144, but since this is a fraction, we should always try to simplify. So a little trick here, if you open up one of your calculators, and then when you're using Notability, if you swipe up from the bottom, you'll see my calculator app. If I press and hold, I can bring it up so that I do see my calculator in screen with Notability. So I'm going to hit 3 divided by 144. Now if I hit enter, it's going to turn my fraction into a decimal, and I do not want that. I want to keep it as a fraction. So a little trick here, if you go 3 divided by 144, on the left, the math button, which is right below the green alpha button, if you hit it, my first option is frac. So what this is going to do if I hit enter, it's going to keep this fraction as a fraction and just simplify it if it can be simplified. And this one can. 3 over 144 is equivalent to 1 over 48. So my scale factor for example 1 is 1 over 48. Doing the same process for example 2, I'm going to go 50 over 12. Now, even though these are diameters, they're both diameters, so they're similar parts of the circle. Now, I don't need a calculator for this. I know they're both divisible by 2, so I can get 25 over 6, and there are no factors of 6 that go into 25, so my scale factor here is 25 over 6. All right, moving on. The circumference of a circle can be found by using one of these two formulas. So these should be familiar from the past. The circumference is 2 times pi times the radius, or pi times the diameter. These are equivalent because 2 times a radius is a diameter. Remember, in a circle, a radius is just from the center to the edge, but a diameter is all the way across the circle through the center. So that's why 2 radii are equivalent to 1 diameter. All right, a small car has a tire with a 17-inch diameter. A truck has a, that should say tire, not time, has a tire with a 32-inch diameter. How much farther than the car will the truck have to drive for its tire to make one complete revolution? Okay, one complete revolution of a tire is the distance around the tire. If you think about it, if a tire is rolling, basically it's going to roll the same distance as one complete revolution, the distance around the circle. So basically I'm just comparing the two circumferences. So for my car, let's see. My circumference is, I'm given the diameter, so I'm going to use pi times diameter, so pi times 17. And for my truck, my circumference is pi times 32. Now, I really don't know how to compare these two in terms of pi. Well, I guess I can go 32 pi minus 17 pi, which is 15 pi. And if they want the answer in a decimal, because I really don't know what 15 times pi is conceptually, bring my calculator back up, 15, and now my pi button, if you can see it, it's the second function just above the divide sign. So I'm gonna hit second and the little caret key, and there's 15 pi. So it's approximately, and I'm gonna use the squiggly equal sign, 47.1. And that is inches. So my truck tire, or my truck, will actually travel 47 inches farther than the car, just doing one complete rotation, so about 4 feet farther. All right, a circular waterfall is surrounded by a brick wall. The radius of the inner wall is 35 inches. I see that in the picture. If the bricks are 5 inches wide, what scale factor was used to determine the radius of the outer wall? Okay, so the radius of the outer wall. So the radius of the outer wall would be this. Now I can see by adding these two, if I put this 5 inches right over here, this radius is 35 plus 5, which is 40. So the scale factor that was used is my outer, or my final over my initial, 40 over 35. I know I can divide both of these by 5, so I guess that would be 8 over 7. So my scale factor to determine the radius of the outer wall is 8 over 7. That's it for today. Thanks, guys.